Good morning, dear children. Hope you all are fine. Let us continue with the chapter Gravitation. Hope you watched the first 3 modules. We have learnt that Earth attracts object towards it, and this is due to the gravitational force or gravity of the Earth. When we throw a stone upwards, what happens? It reaches to a certain height and then it starts falling down. Or we say the stone falls freely towards the earth, or more clearly we can say that the stone is under free fall. Look the bungee jumper here. The jumper is falling down only under the gravitational force of the earth, or he or she is said to be in free fall, or we say falling freely. So when an object or when a body falls from a height towards the earth under the gravitational force of the earth with no other forces acting on it, it is said to be in free fall. So such a body is called a freely falling body, and so whenever an object falls towards the earth on its own, we say that it is under free fall, or that is a freely falling body. So what is free fall? The falling of an object towards the earth under the force of gravity is called free fall. So let us discuss more about it. Children, we know that when an object falls freely, there is no change in the direction of motion of that object because it is falling down. But is there any change in the velocity of the falling objects? Yes. Due to the Earth's attraction, there will be a change in the magnitude of the velocity. And you know that any change in velocity will involve acceleration. So we have studied it. When an object falls down, its velocity goes on increasing, and when an object is thrown up, its velocity decreases. So here we are talking about objects which are falling freely due to the gravity of the Earth. So these objects, the rate of change of velocity of these objects will be constant, or we can say that it will have a uniform acceleration. So a uniform acceleration is produced in a freely falling object by the gravitational pull of the earth. We have already studied. When we studied about uniform acceleration in the chapter motion, we understood that freely falling objects are good examples of uniform acceleration. Now, let us understand whether this acceleration depends upon the mass of the falling object. Our Earth attracts all the bodies or objects which are near its surface. So that when a body, for example a stone, is dropped from the roof of a house or from the top of a building, it falls down to the earth. But children, earlier in ancient times, it was thought that the lighter objects fall slowly and the heavier objects fall more rapidly. That means more faster when dropped from the same height and at the same time. Many experiments were conducted during the ancient times, and the scientist, philosopher Aristotle, he said that when an object is undergoing free fall, the speed of the object will be proportional to its mass. That means more the mass of the object, faster it will reach to the earth. So this statement was contradicted or was opposed by Galileo Galilei. So Galileo Galilei, he climbed the Leaning Tower of Pisa, and there he conducted an experiment where he dropped 2 balls of different masses but having the same shape. And he found that they hit the ground at the same time. And he concluded that acceleration of an object which is falling freely towards earth does not depend on the mass of the object. So let us go through a video.
Aristotle. Born in 384 BC in ancient Greece, he was a famous philosopher. He also made great contributions to many other fields such as ethics, politics, and science. One of Aristotle's most famous contributions to science is actually based upon a false claim. For years, Aristotle preached that heavy objects fall faster than lighter objects. stating that the speed at which something falls actually depends on its weight. He would explain it to anyone that would listen. His example was that an object 10 times heavier than another would have to fall 10 times faster. No one disagreed with Aristotle. Most people were comfortable with the idea of heavy objects falling faster because it's what they were used to seeing. For almost 2,000 years, Aristotle's rules for falling objects remained unchallenged until a new scientist attempted to prove him wrong. Oh, you're probably wondering what I was doing. Well, that's none of your business. But what is your business is the Leaning Tower of Pisa, a building famous for its improper construction. When it was built in the 1100s, part of the foundation began to sink, which is why it now leans to one side. Another reason why this building is famous has to do with the dispute between Aristotle and our next scientist. In the year 1589, an Italian scientist named Galileo attempted to prove Aristotle wrong. Galileo believed the only reason heavy objects fall faster is because air resistance slows down lighter objects, and that if air resistance could be reduced, they would both fall at the same speed. In order to prove his point, he gathered everyone in the city, climbed to the top of the Leaning Tower of Pisa, and explained that the only way to prove who was right for sure was to perform a scientific experiment. Galileo's experiment went like this. He stood at the top of the Leaning Tower and held out a cannonball and a wooden ball of the same size. The only difference between the two objects was their weight. Galileo explained that since they are the same size and shape, they would feel the same amount of air resistance as they fell. His conclusion was that they should hit the ground at the same time. So he leaned out over the edge, dropped both objects, and a little more than 3 seconds later, everyone in the city of Pisa saw the cannonball and the wooden ball land at the same time, proving once and for all that if there is no air resistance, all objects, no matter how heavy, will fall at the same rate.
Thus, Galileo proved that the acceleration of a freely falling object towards the Earth does not depend on the mass of the object. Earth pulls all objects in the same manner. During free fall, both the heavier objects and the lighter objects accelerate at the same rate. So during those times, many experiments were conducted, especially a feather and metal coin. A feather and a metal coin were dropped simultaneously from a roof. It was seen that the metal coin reached the ground first and the feather took more time to reach the ground. So Galileo, he suggested that the slow speed of the feather while falling might be due to the larger surface area of it as compared to its mass. That's why the feather experiences more air resistance and its speed is slowed down. Whereas the metal coin is small and heavy and it does not get much air resistance, and so it falls to the ground at a faster rate. So he said that if there were no air, the feather and the coin would fall at the same rate. Later, years after, Robert Boyle, he's known as the father of modern chemistry, he invented vacuum pump, and through his instrument he proved that what Galileo has said was right. So let us go through some activities or some experiments related to it, which was recreated later.
Galileo had a big idea. His idea was that all objects fall to Earth at the same speed, regardless of their mass. This experiment shows that Galileo was right. As you can see, the feather falls slower than the coin does. This is because the feather and the coin are falling through air, and air is made up of stuff. And this stuff pushes up on the feather and the coin. This is what we call air resistance. Now, air resistance has two factors. One, the mass of the object, and two, the surface area of the object. So our feather is very light, it has a small mass, but a very large surface area. So that means it falls slower due to air resistance than the coin does. So now we've removed all the air from the tube and we've eliminated the air resistance. Now our coin and our feather will fall at the same speed. Galileo was right.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest. Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCV 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Exactly. Exactly. They came down exactly the same.
So, children, from these experiments, we understood that the acceleration produced in freely falling bodies is the same for all the bodies, and it does not depend on the mass of the falling body. Now, coming to the main point, when an object undergoes free fall, a uniform acceleration is produced in it, and this acceleration that is experienced by an object falling freely due to the force of gravity is called acceleration due to gravity. Acceleration due to gravity is denoted by the letter G. Acceleration due to gravity does not depend on the mass of the body, as we know, and the value of G slightly varies from place to place, but for most of the purposes, the calculated value of G, that is acceleration due to gravity, is taken as 9.8 meter per second square. So what do we mean when we say that the acceleration due to gravity at a place is 9.8 meter per second square? Children, look the data that is given here and look the figures. An object is dropped from a height. So at the time of dropping, the initial velocity is 0. That means at 0 second, the velocity is 0 meter per second. But as the object is falling freely, we know that its velocity goes on increasing from 9.8 to 19.6 to 29.4 and to 39.2 just before it touches the ground. So there, look the change in velocity. In every second, we can see that the velocity is changing or increasing by 9.8 meter per second. Or we can generally say that when an object falls to the ground, under the action of the Earth's gravity, its velocity increases at a constant rate of 9.8 meter per second in every second. That is a calculated value, children. And when an object is dropped freely, that means it falls with an acceleration of 9.8 meter per second square. That is the meaning of that. Every second, the change in velocity will be 9.8 meter per second. Similarly, when an object is thrown vertically upwards, it undergoes a decrease in velocity or a retardation of 9.8 meter per second square. So we will just try to form a formula to calculate G. In the coming class, we will do that, and there we will find the value of G. So stay tuned. See you. Thank you for listening patiently and stay safe.